question number 11 from section 2.3 function. It is the following. An equation that defines y as a function of f of x is given. Solve the equation for y in terms of x and replace y with the function notation f of x. That's part A. And part B is to find f of 9. So what we're given here is an equation, x plus 5y equals 13. We want to solve for y in terms of x. In other words, we want to get the y by itself. We get the y by itself by subtracting x from both sides of the equation, and that gives us 5y equals, you can write this as 13 minus x, or even negative x plus 13. And then to get the y by itself, we're going to divide by 5. You can write this as y equals, you can write this as a fraction, negative x divided by 5. That's the same thing as negative 1 over 5x plus 13 divided by 5. Now we want to replace the y with f of x. So we get f of x equals negative 1/5 x plus 13 over 5. Enter the answer. Plus 13 over 5. And check. Now the second part of this question is to evaluate f of 9. To evaluate f of 9, you're going to replace the x in the equation in the function with a 9 plus 13 over 5 and simplify. Negative 1/5 times 9 is negative 9 over 5 plus 13 over 5. We can add these together because we have a common denominator. Negative 9 over 5 plus 13 over 5. We simply add the numerators. Negative 9 plus 13 is 4 over 5. We've evaluated the function for the given value. Let's look at number 12. For number 12, we have an equation that defines y as a function of x. We want to solve for y in terms of x and replace y with the function notation and then find f of 3. So this is a lot like the last one. We want to solve by getting y by itself. If we subtract 6x from both sides of the original equation, we get negative 6y equals negative 6x plus 1. We divide both sides by negative 6 and simplify the results. This time what I'm going to do is just, actually we'll leave it like this. Y is equal to negative 6 divided by negative 6 is 1x, or just x. And then 1 minus 6 would be 1 divided by negative 6 is minus 1 over 6. Then we replace the y with the function notation f of x equals x minus 1, 6. Oops. Excuse me. Sorry about that. And we get x minus 1 over 6 as our function f of x. Part B, we want to evaluate this function at 3, for x is equal to 3. F of 3 is equal to 3 minus 1 over 6. You can use a calculator here and write the answer as a fraction, or you can get a common denominator. With a graphing calculator to simplify 3 minus 1, 6, you type in 3 minus 1 divided by 6 and press enter. You get a decimal value. That is the program is not going to accept that decimal answer, so you want to convert it to a fraction. You're going to press the math button, choose number 1, that option for fraction, and press enter. You see that this fraction is the same thing as 17 over 6. And we can check that answer on the program. Excellent. Just two more problems. Number 13. From the graph of the function, find the intervals on which the function is increasing, decreasing, and constant. Now to figure out where these are increasing, decreasing, or constant, let me just make this a little bigger so we have a reference here. When you're determining where the function is increasing, where it's decreasing, and where it's constant, we are looking at the graph from left to right. It looks like it's going up in both of those directions, but actually one of those is increasing, one of those is decreasing. First of all, the increasing part, oh, actually, you know what? You could see this graph is broken up into three parts. We have this part over here, where the graph is actually going down the page from the left side to the right side. We would call this part of the graph decreasing. And then we have the part in the middle here, where if you go from left to right, your pen isn't going up or going down. It's remaining constant. So that portion of the graph is constant. And then the last piece of the graph is, you can see the graph is going up. Let's do this color here. From the left side of the graph to the right side of the graph is going up. So on that part of the graph, the function is increasing. So when we give the intervals where the function is increasing, we want to see where the increasing starts. It actually starts right here at the value of 3 on the number line. We're going to put a bracket 3, and it's going to continue to increase as x goes to positive infinity. This graph is going to continue to increase. So the interval is from 3 to infinity. The interval where it's constant is that interval in the middle. And that interval starts at this x value 3 and ends, x value negative 3 and ends at the x value positive 3. So where it's constant is from negative 3 to positive 3. And then the interval where the function is decreasing is that first part of the graph where it's actually going down. Even though the arrow shows us going up, from left to right, this graph is going down. So the interval where this function is decreasing is all the way over here on the number line to this x value on the number line. That is from negative infinity to negative 3. And remember, we always put the parentheses by the infinity. The very last one is similar. We have a function and we want to determine the intervals where the function is increasing, where it's decreasing, and where it's constant. Making this a little bigger to really show you the detail of this graph. The portion where the function is increasing is just the portion where the graph is going up from left to right. So you look at the corresponding x value here at 0 to the x value here at 1. The function is increasing from 0 to 1. The function is decreasing. That's the portion where the graph is going down as you go from left to right. This part is decreasing. So the interval where it starts to decrease here is 1, and it stops decreasing here at the x7. So from 1 to 7 is the interval where the function is decreasing. And the interval where the function is constant, that's going to be the flat part of the graph. Okay. And the x value where it starts being constant is -1, and the x value where it stops being constant is 0. So this graph is constant on the interval from -1 to 0. Notice these are all x values, where for the intervals where the y values are changing. Good job, and we are done.